Alright, we are back with our last video of Unit 9. In this video, we're going to be putting everything together. We're going to put it all in one place. We're going to graph rational functions. Right? To graph rational functions, we're going to have to find these features, these key features of a rational function. Okay? Remember to find the zeros of our function. I set y equal to 0 and solve for x, which you've been doing for a long time. To find the y-intercept of a function, same thing. You've been doing that for a while too. Set x equal to 0 and solve for y. Okay. When finding holes, all right, remember in finding holes, we want to make sure that we factor. All right, after we factor, okay, the holes are what cancels any factor that cancels in the numerator and the denominator. All right, that cancels them both out. Remember, after you find the hole, you'll have your x value. Okay, I want to make sure that I find my y value as well, so that I can write my hole as an ordered pair where it's x comma y. Okay, that holes are written as coordinates. Okay, remember to find vertical asymptotes. They're the factors that do not cancel. Okay. Are factors that are in the denominator that do not cancel with the numerator. Remember, vertical asymptotes are always written as x equals some number. Lastly, our end behavior asymptotes are found by dividing the numerator by the denominator. Okay, either have a horizontal or a slant asymptote, and those will both be written as y equals. If it's horizontal, it'll be y equals some number. If it's slant, it'll be y equals some polynomial. Okay. Two more tips I'm gonna throw at you here. Just some little shortcut. I don't like using the word shortcut. It's not really a shortcut. Just a little reminder. I'm gonna type it out because my handwriting isn't the best. So I use the factored original. Like when I have my polynomial, all right, my rational function, I factor the top and the bottom. I factor my numerator and denominator. My factored original will help me determine my domain and my x values of my holes. Okay. Once I simplify my rational function, cancel out my holes, cross out my holes. All right. My simplified version will help me find the y value of my holes. Hole or holes. This will help me find my vertical asymptotes and my end behavior, buckets, asymptote. Buckets. There we go. All right. So my factored form will help me find the domain of my x values. My simplified original will help me find my y value of my hole. Okay. My vertical asymptotes, or my end behavior asymptote. All right, so let's put it all together here. Let's put it all in one. So the first thing I need to do is to factor. All right, so I'm going to factor the numerator. It's going to be 2 times x squared minus 9 over my x squared minus 4, which will give me x plus 2, x minus 2. And I'm going to keep going in my numerator. 2, x plus 3, x minus 3, all over x plus 2, x minus 2. Okay. First thing, I want to find my vertical asymptotes. Remember, the vertical asymptotes are found when I simplify. So I cannot cancel anything out here. There's nothing that crosses out, which tells me I won't have any holes. So when I go down the holes, I can write NA. I can write no solution. I'm just going to write none. There are no holes. All right. Vertical asymptote, when my denominator cannot equal, what's going to make my denominator equal to 0? Well, here, x cannot equal -2. So x equals -2. Here, x cannot equal 2. So x equals 2 is a vertical asymptote. All right. Horizontal or end behavior asymptotes, okay, we did the holes, with the vertical asymptotes, are found by dividing the numerator by the denominator. Okay. So if I look here, this is my simplified form. All right, I divide my numerator by my denominator. Okay, well, if you realize now I'm going to have a I want to think about it as bottom heavy, top heavy, or even heavy. Well, if I think about this top, I'm going to have 2x squared on top. If I think about the bottom, I'll have x squared on the bottom. All right, as you can see back in my original, x squared and x squared, even heavy, which means that I take the leading coefficients, so 2 and 1, and divide them. So my horizontal asymptote is y equals 2. If there's a horizontal, there won't be a slant. X-intercepts are found when my numerator is equal to 0. Because really, what am I doing? I'm taking this entire function and setting it equal to 0, right? Well, if I set this entire function equal to 0, I multiply both sides by x plus 2x minus 2. Okay? That'll disappear, so I'll have 2 times x plus 3, x minus 3, equal to 0. X-intercepts are when your numerator is equal to 0. Well, here, I'll get negative 3, I'll get positive 3. 2 does not equal 0, so I can ignore that. So my x-intercepts are negative 3, 0, and 3, 0. Lastly, I want to find my y-intercept. My y-intercept, I can plug it into any here, here, or here. Okay, I'm going to plug it into my original, because you'll see this is a lot easier. All right, this becomes 0, this becomes 0. So I have 0 minus 18 over 0 minus 4. I'm just showing this work you could do in your head. 18 over 4, which is 9 over 2. So my y-intercept is 0, 9 over 2, which is 4.5. All right. Now, I want to throw what I know. I want to put all of this onto here. Okay. And then the last thing I'm going to do is actually look at the function. So our goal here is to try to not use our graphing calculator. We want to be able to do this without using our graphing calculator until the end. So I have vertical asymptote at negative 2. And positive 2. What the heck? Okay. I have a horizontal asymptote at y equals 2. Whoops. Okay. Hold on. Apologize for that. X-intercepts. I have negative 3 and positive 3. Y-intercept 0, 9 over 2, which is 4.5. All right, so now if we think about this logically before I look at the graph, all right, realistically my function is going to have to do something like this here, open up here, and that there. Okay, just because of how we think about it. It's because, I mean, it can't go down because I'll hit an asymptote. So let's look at this graph. If we look at this graph, I'm going to pull, here's my y equals right here. 2x squared minus 18 over x squared minus 4. All right, look at this graphically. My guess was right. I'm going to have an upward facing parabola on top and something like this and like that. Okay, so I want to make sure you hit your key features. Hit my key features. And hit my key features. Alright, so this over here on the left are your key features. Okay, these are your key features of your graph. Okay, when doing this on a test or a quiz, we would like to see these points. We like to see these vertical asymptotes. Okay, the only time you're really going to be able to use your calculator is this part, just to see what the function actually looks like. But other than that, we need to see these key features. Alright, next one. I'm going to change this to x squared plus x on the top. Okay, I want you to factor and simplify this one. So I factored and simplified. My simplified version told me I have a vertical asymptote at x equals 2. Remember when we simplify here, all right, whatever cancels out is going to determine my whole. So my whole is going to have a negative 1, an x value of negative 1. To get my y value, plug negative 1 into my simplified version. Negative 1 over negative 1 minus 2 will give me negative 1 over negative 3, which is positive 1/3. Okay. Horizontal asymptote, look at the simplified version. Our degrees are the same. All right, so my horizontal is y y equals 1. If I have a horizontal, then there isn't going to be a slant. My x-intercepts, when my numerator equals 0, so x is 0, and my x-intercept and my y-intercept are the same. Okay, because if I set my numerator equals 0, I just get x equals 0, right? Okay, when x equals 0, oh, y is 0. How about that? So that tells me that this is a very important, a key feature. Y equals 1 is a key feature. X equals 2 is a key feature. I have a hole. Figure out what we know, and knowing what we know about rational functions, my function should look something like this. How would I know for sure? Oh, if I don't know for sure, I can always graph it. Boom. It should look something like that. Now, we can't see the hole, but if you look at your graph and use the trace feature, you'll know that there actually is a hole. Okay? I want you to factor and simplify this one. Throw what you know. So, here's what I knew for sure. Okay? My vertical asymptote was x equals 1. Because nothing canceled, there weren't any holes. It's completely simplified. So no holes, no horizontal asymptote. Well, how did I know that? I realized I have a top-heavy function here. Okay, I have x squared over x minus 1. So that tells me that I have to use synthetic division to find the equation of my slant asymptote. 1 comes down, 1 times 1, 0. 0 times 1 is 0, negative 2. Remember, we disregard the remainder and only care about our coefficients that will give us a linear function or a function. So y equals 1x plus 0, y equals x is my function. My x-intercepts, when the numerator equals 0, I have 2, 0, and negative 1, 0. When my numerator equals 0, that's where I find my x-intercepts. Y-intercepts, 0, 0, 0, negative 2 over negative 1, which gives me 0, comma, negative, or excuse me, 0, comma, positive 2. Positive 2. I want you to grab this while I'm struggling to write. There we go. Throw what you know on the graph, and then we'll talk about the slant asymptote. All right, so the slant asymptote of y equals x, okay, that tells me that my slant asymptote is y equals x. That tells me that the slope of my function is 1 over 1, so and my y-intercept is 0. So I start at 0, 0, and draw a slant asymptote, go up 1 over 1, up 1 over 1 in both directions. Okay, look at that sick line that I just made. Wow. With a slope of 0. Isn't that neat? That's so neat. Thanks for thinking that's neat. I appreciate that. Anyway, so now that I have all my key features plotted, all right, I want to look at my graph. Well, if I know anything about functions, which we all do, I'm going to guess that this is going to go right here. I'm going to have a function like that as well, seeing that I have nothing over here and nothing down here. So let's look at my graph. Last one of the day. Don't cry. Oh, how about that? I was correct in my guess. So I'm going to go back to my original, hit my key features. Hit my key features. Boom. And there you go. That's what putting it all together looks like. All right. So now let's review just a little bit. Remember that you find your zeros, or I said y equal to 0. It's when your numerator is equal to 0. Y-intercept set x equal to 0. Holes, to find holes, I find my x value by what cancels out. All right, and then I find my y value by plugging it back in to the simplified version. Vertical asymptotes is going to be x equals some number. Horizontal and slant are found by dividing the numerator and denominator. Okay. Now, we are also able to ask you a lot of questions from this if I wanted to evaluate a limit at a certain point, or evaluate a limit as something goes to infinity. As x goes to infinity, the limit's going to equal positive infinity. As x goes to negative infinity, my limit would equal negative infinity as well. Or I could have you evaluate it as x equals 1. All right?